Okay, so it's time to look at problem 3 as always. This is a graphing problem, so if you have not already done this one, stop the video, do the problem, and then start back up again. So, okay, let's see what we got here. So we're being asked, we're told that the graph of the function f is shown, and we're supposed to let g be the function defined by the definite integral, right, of f, basically. So we have to find these different values, g of 4, g prime of 4, g double prime of 4. Let's do it. So what is g of 4? Let me do this in blue. So g of 4, right, is going to be the definite integral from 0 to 4 of f of t dt. What's that equal? Well, I think you guys would agree. We are talking about the area from the curve to the x-axis from 0 to 4. Let's see, 1, 2, 3, 4. So we're talking about all this. Let me just double check it one more time. 1, 2, 3, 4. We're talking about all that. Okay, so they're not asking you to show your work. This is kind of up to you. Here's going to be my thought process on it. Okay, I'm going to go kind of quickly here. So this and this cancel each other out. So that's 0. And then I could do the area. I could go. So I'm going to say the area of this rectangle, which is 1 by 2. And then the area of the trapezoid, which is 1/2 1 by 2. So it's a total of 3. You don't need to simplify it, but there it is. Okay. So hopefully that makes sense. Let's move on to g prime of 4. So g prime of 4, right? Let me just kind of erase this stuff here. G prime of 4, well, is going to be equal to, well, let's take a step back for a second, just to make sure we're good. G prime of x equals f of x, right? Which means g prime of 4 equals f of 4. And what does f of 4 equal? F of 4 equals 1, 2, 3, 4 equals 0. Okay, then we're asked to find g double prime of 4. So g double prime of 4 is going to be f prime of 4, right? In other words, it's going to be the derivative here. The derivative is going to be the slope of the tangent line passing through this point. So in other words, I'm going to find the slope of this line. So I think you guys would agree. Actually, it looks like it's just -2, right? It goes down to right 1, so it's -2. Boom. There we go. Let's move on. Does g have a relative minimum or maximum at x equals 1? So x equals 1 is right here. Does it have a relative minimum or maximum? Well, remember, or neither, of course. So first off, I think you'd agree there's definitely a critical number there because g prime of x equals 0. So g prime of x definitely equals 0 there. So it's definitely a critical number there. If we were to make a quick sign chart at 1, I want to remind you this doesn't count. This is for us. To the left of 1, the derivative is negative. To the right of 1, it's positive. So what do we have? We have a relative minimum. So what am I going to say? I'm going to say at x equals 1, there, let's say g. Let's just call it g has a relative minimum because, now remember, you got a point. So I'm going to say because g prime of x, which equals f of x, right? So I'm saying, hey, I'm looking at f of x. So I want to find out information about g, and I'm looking at f, and here's how I'm doing, okay? I took the derivative of g. So because g prime of f equals f of x changes, and what did it do? It changed from negative to positive at that point. So changes from negative to positive at that point. Okay? So there's a relative minimum there because g prime of x equals f of x changes from negative to positive at that point. Man, my handwriting's going down. I got to clean that up. Okay, let's keep on going. Okay, so this is an interesting one, and I am going to grab this graph. I believe that I need it. Kind of. Let's put it right here. Okay, let's see what we got here. So suppose that f is defined for all real numbers x. with a period length of 5. Reminder, period length just means, when we talk about a period, it just means that something's repeating over and over again. So when we talk about sine, right, sine has a period length of, 2 pi. It repeats every 2 pi, right? So this has a period length of 5, which means, it starts here. So if this is the start, it ends here. This is 5 units away. Then it repeats 5 units away. It's going to repeat 5 units away. You can't see my hand. It's off the thing. But hopefully you get the idea. So we got to find out a couple things. So they tell us the g of 5 equals 2. The first thing we have to do is find what is g of 10. Well, I think you'd agree g of 10 is going to be 2 of these, right? It's just going to be 2 of these. So in other words, it's going to be equal to 2 times g of 5, which is going to be equal to 2 times g of 5 was 2. So it's going to be equal to 4, okay? Now, the reason they gave us that is they wanted us to kind of get in the thought process, because it's really all about this next question. Did they ask us to find g of 10? Because I didn't see that. Wait, hold on. Find g. Okay, now they said find g of 10. Well, I think you guys would agree. This was, by the way, this was g of 2. Why did I do g of 2? Oh, no. That makes sense. I'm sorry. I'm sorry. I got totally confused. That makes total sense. G of 10 equals 2. Right. Yeah. I'm sorry. I was thinking 2 periods. So that just kind of, sorry. Ignore that. Let's keep on going. Now they ask us to find the equation of the tangent line at x equals 108. So I think you could agree. We need to know 2 things. We need to know the point. So in other words, I need to know this, and I need to know this. Let's start with the point. Let's start with the point, because that's kind of what we just did above. So I think you guys would agree g of 108 is going to be equal to, so if I take 108 and divide it by 5, right, because those are all the periods, I think it's 21, right? Yeah. So I'm going to get 21 times g of 5 plus that remainder, right? So plus g of 3. Okay? So in other words, I get 21. G of 5 was 2. G of 3, right? I don't know if we've already done this before, but it's this plus this, which is 0, plus this, which is 2, right? So g of, g of 3 was 2. So our total is 21 times 2, which is 42, plus 4 is 44. So g of 108 is 104. Sorry, is 44. Excuse me, is 44. Hopefully that makes sense, right? So again, well, I'll let you think about it. If you have questions, you can always ask. But again, I asked myself, how many periods were there in 108? So there was 25 periods, but there were 3 remainder. So I did like I did here. When I said g of 10, I said there was 2 periods. Each one was, an area of 2. In this case, there was 21, and I added the remainder period. Now, the next thing we have to do is we have to find what is g prime of 108. Well, I think you'd agree g prime of 108. So every period starts down here, right? Boom. It always starts down here. So g of 3 is going to be this right here. We're basically, g of 108 is going to be the same thing as, it's going to be equal to g prime of 3, right? Because this thing keeps on repeating over and over and over again. So we're looking at g prime of 3, which is 2. So we have a slope and a point, right? Our point is the point 108.44, and our slope is 2. So our equation of our line is going to be y minus 44 equals 2 times 108. And I don't think they asked us to write it in terms of, nope. It doesn't ask us to write it in terms of, f of x or y equals f of x or anything. So we are done at that point. So I will see you in the next video.